right? This is the order of reaction. This is the order of reaction, and the unit of rate constant will depend on the order of reaction. This alpha and beta depends on which number that you get from the stoichiometry, right? This alpha and beta will depend on the number that you get from this. Depends, for example, remember you did the practicals, you have to find out your stoichiometry, and yes, that stoichiometry will be linked to the order of reaction. Okay, let's move to your lecture note, page 13. 13. Last time when you were younger, 13 years old.
What the heck?
Okay, let's consider this second order elementary reaction. Okay, I also will try to recap a little bit by bit when I see some certain keyword that we use here. For example, this is the second order elementary reaction. Big word, elementary reaction. This elementary reaction is for us to indicate that when we see the word elementary, you have to bear in mind that it gives you the information to write your rate of reaction. This actually will link to how actually you finalize the rate of reaction. Okay, this piece of information is very important. For example, this is considered second order elementary reaction. Look at this. Why we say this is second order? Because of these two. Second order. Because of the stoichiometry in front of this A. 2A reacted together give you your product. Okay. And for now, right, we only focus on the starting material first. Okay, we are not focusing on the product at all. So the rate of disappearance of A is minus RA, rate of disappearance. I always say rate of disappearance equal to K Ca squared to Ca squared. And the order of reactant A, order of reactant A is 2, right? Order of reactant A is 2. And we look at this now. If the order of reaction, okay, the order of reaction is correspond with stoichiometry. The order of reaction is respond to the stoichiometry. The order of reaction is circled here. Respond to the stoichiometry. Therefore, this is the elementary reaction. This is the elementary reaction. So now let's say, you can see that this square is actually the same as the stoichiometry here. Therefore, this is the elementary reaction. Okay, so now you know roughly that when I see the word elementary reaction, I know that this piece of information what is that mean for this piece of information. So for this, right, rate of disappearance of A is minus RA equal to KCA squared. Okay, and we have to recall a little bit of the topic 1, right? Basically, minus RA is also equal to minus 1 over V dNA over dt. Still remember this? Okay. This, because this reaction is actually in liquid form, therefore this is considered as the per unit volume basis, right? Remember over VC is per unit volume basis, right? Per unit volume basis, because the reaction rate will depend on the, of course, will depend on the molar, and it must be depends on the how big is the volume. That must be taken into consideration. Okay, since the minus RA is also equal to this whole thing, then therefore we can substitute that this minus 1 over C d NA over dt equal to KCA squared. Okay, after that we try to work it out. Okay, and this, the main idea of this is to find out the units of K. We have to find out unit of K. And we compare both units together, right? Okay, look at this carefully. This portion is actually equal to this portion. Okay, yes. Okay, because why we have to link this up? Because these two pieces of information can give you the unit of K. Okay, now we have to find out what is the unit of K. Okay, unit of rate constant. And NA, what is the NA stand for? Is mole, right? NA stand for mole, right? V is volume. T, time. Okay, this volume can be, of course, can be liter, cubic meter, etc. Or time, it can be, or time can be more option, right? Like for example, second, minute, hour, etc. And for this CA square, okay, CA is represent concentration. This concentration is obviously mole per unit volume. For example, our practicals H2O2 we use is 0.5 molar, right? I try to link with what you actually experienced before. Okay, that's why I think you can connect the thing better. For example, you see, this is the unit of concentration. Okay, this unit of concentration is 0.5 mole per liter. Therefore, the concentration here is mole per volume. Okay, once you already substitute everything, right, you work it out. The unit of K, it will be equal to volume per mole per time. Okay, just now I from the lecture note it say that the unit of reaction, this one is page 12, page 12. Unit of K will depends on the order of reaction. Will all depends on the order of reaction. This one you circle, highlighted here. Why I say that it depends on the order of reaction? Because if you look at this, our main equation, right? Number 2 here, right? Just now I said, you see number 2 here is actually the order of reaction. Order of reactant A. And imagine if this number, because you see in this equation, right, this portion will be remain the same. But the thing that vary, it will be the concentration, concentration also the same. But the thing it can be vary is the order of reaction. It can be 1, 1.5, 3, 5, 10, etc. So therefore, the power here will actually reflect mainly to the unit of K. Okay, this one will be impact to the unit of K. Okay, so now how are we going to be more clear about this, right? We have very good examples. Example 2.6 in your next slide, next page, page 14. Okay, let's look at this question together. For this, right, given the unit of concentration is, you see the unit of concentration is mole per liter. Unit of time is hour. Determine the unit of rate of constant K for the following elementary reaction. You see, just now I emphasized, spend about 5 to 10 minutes to emphasize on this. Now you can see elementary reaction. It means that your stoichiometry will be correspond to the order of reaction. Now you remember, elementary, the meaning is stoichiometry same as the order of reaction. Okay, let's look at the first question. The first question, the stoichiometry is 1, right? And for this stoichiometry, let's say if you have to come out with the rate of disappearance of A, okay? Now we have to find out, okay, this question, it actually will be nicely matched to the previous slide, previous lecture note. You can actually refer to the previous lecture note together. First, we have to find out what, because these two we can link up together, correct? This one is already is constant basically, but KCA, now CA is no longer square already. It actually 1. Yes. So for example 2.6, I show you one by one slowly. Well, let me explain to you first, and then I will give you enough time for you to copy. Is that fair enough?
Yes.
Okay, I want you to listen first. At least you go here and then you digest, at least something still here. Okay, in order to do this calculation, first important thing is come up with the rate of reaction. The rate of reaction, just now I mentioned, elementary reaction. The rate of reaction here, the order of reaction A will be same as number 1 here. Wow, this one easy, come out. Okay, this one can already. After that, the rate of disappearance of A will also equal to 1 over V, dNA over dt. This one is the same as just now, right? So now we can link up these two, because RA, we don't know what is the unit of RA, but this portion is the portion that we can finalize the unit. Therefore, these two we combine together. Once we already have KCA equal to minus 1 V dNA over dt, we work it out. Okay, we work it out. This one don't copy first. Later I give you enough time to copy. Okay, this one is very important. This one I think you can do one. Okay, but this is the main, is the most important part. Okay, because you have to look at the equation. The volume 1 over liter. 1 over liter. Ca, the concentration is mole per liter. Mole per liter, just look at the equation. dNA is mole, right? dt is hour. So after you work it out, you will get the unit of K is 1 over hour.
Oh my god.
And that's it, you see. Okay, now I give you time to digest.
Yeah, bless you, sir. Huh? PIA? Week 4? Is it flex week?
Oh, sorry, week 5.
Huh? Come back already test
Yeah.
Then go
This one
to...
also what? PIA.
How many tests is there in week 4?
This one,
week 5.
then PIA.
Wait. This is CRE, right? CRE, PIA.
12 November.
Some what?
12 November is PIA. 12 and then, when is CRE? 13 November.
Or next day. Then some more got what test? You all have what?
The I'm not sure. So it's 12 and PIA also I'm not sure. What, we got 5 topic subject.
5 or 8?
PCI got lecture test also I think. 12 oh, PIA.
Holy shit.
What colour shall school start with?
We get turquoise.
Okay, I'll ask. What's 10 minutes? What's 10 minutes?
Before, after, like they tell you something.
Okay, can I continue?
For the reminder.
Okay, why do we have to know the unit of K? Okay, because regardless any reagent you use, maybe your reaction have, okay, look at this reaction. This reaction only have one reactant, which is A, correct? But in the case that in the future, the reaction you see, it will be more complex. It could be 2, 3, and more reactants. Alright? However, even though there are many reactants, but if the rate of reaction is actually 1. Sorry. if the order of reaction is actually 1.
Oh, so I cannot walk.
If the order of reaction is 1, so basically, the unit,
3
it
to 4
will be
lah.
the same.
No, after that.
As long as the order of reaction is the same,
So I cannot walk.
regardless how many reactant you have. Okay, why this one is very important? Because by looking at the unit in the future, by looking at this unit, you know that, oh, this reaction, the order of reaction is 1. Because if the order of reaction is 2, it will be another unit. So, because in the future, you have to be able to predict also that, wait, what is the order of this reaction? Okay, and then you can say that, oh, because the unit of K is 1 per hour, therefore the rate of reaction, the order of reaction is 1. Okay. What about if the order of reaction is 2? Order of reaction is 2. What we have? Basically, it's the same concept.
Am I not wearing the same thing?
More like mine is every
Plain shirt and plain pants.
Because I always have like that few like and then so that's how I should buy this. It's the newest school, like quite
More decent people to wear to school. Have you seen the book? Blue color.
My parents be like, what's wrong with extra, I already have slippers. That extra for what? Not like these two slippers, don't know do what slippers, do what kind. Like that, right? Then all my clothes, all every day I wear is Monday clothes, Tuesday clothes, Wednesday, Thursday, Friday, Saturday clothes. Then every week I wear the same thing. Or else every
You don't wear shorts to church, right? Very long pants.
I used to fancy.
Okay, for those who already copy finished, right? Can you try to do question C? Example 2.6C. The order of reaction is 2.5. How to do?
Yeah, exactly.
Okay, give you a hint. Give you a hint. Later on, right, for question C, right? Question C, the rate of reaction will be KCA to the power of 2.5. KCA the power of 2.5, right? Because the order of reaction is 2.5. So now can you see the link? Now you can actually link up between this whole thing. This whole thing is basically is a consistent one, right? You see, this one we change according to the order operation, it still remain the same, consistent.
So what?
So basically, in the
So it's
next time, CA is 2.5, right? This will be equal to K CA 2.5.
Yeah.
Right.
You can sing also for the
Okay, after that, you try to work it out.
If you know the like method, right, of how they do it, right, then don't need to do it.
Try. Exercise your brain now,
Huh?
Yeah.
Yeah.
The more you exercise your brain, your brain will getting bigger and bigger, more complex,
Okay lah, but makes sense lah. I mean, if you like that, the volume 1.5.
Negative.
Then like that. Okay. Yeah,
For the A, which A? Question A.
literally repeat.
Yes.
So is it a negative?
The unit does not.
There's no negative.
Let me
It's not
double
supposed
check.
to negative because after that he flip already one. Flip it the other way around. So means it's 3 positive. Or the K we got negative.
Yes.
1 over mole over L, right? Times 1 over. Then he flip the thing over. No, the negative is coming from the volume. 1 over.
Right?
Yeah.
Must be
Yeah, but then
minus.
after that
The unit does not have negative value. The whole thing is then replaced with the whole unit, that whole unit. They stated here it's negative until here, but the whole negative, this whole thing equals to this unit. So there's no negative.
So there's no
for that.
negative.
Yeah.
And also because he flip the right, when you flip the
Okay,
unless something
ready,
Yeah. By right, it should be
I think this one also negative.
doesn't make sense as a negative. Sure, but why is there a negative? Okay lah, maybe up to
So why unit has a negative?
maybe
Yeah.
like before the repeat lah, but like why your hour also got one?
So why your unit got negative?
Why the hour also got
Calm down. He say wait.
why the hour also got why the hour got 1.5?
I don't. Okay, why you I'm so calm.
Why you like want to fight there? You got big power, is it?
Huh?
You got big power, is it? You like want to fight?
No.
You mean why the C got negative?
Ah, innocent. Where's Arvin? Where's Arvin? Arvin, where's Arvin?
Abi, I think he not with your friend.
Your best friend, right?
Your best friend, right?
Your friend got very good.
My friend got one.
Because if you look at this,
Which friend is it?
No, the
Abi.
this one actually is minus 1 over V.
no,
The
no.
smoke smell.
So the negative will be stuck all the way till here.
No, it sucks. It smells sucks. That's what it is.
Yeah.
How is that? It's the worst smelling thing ever.
From this calculation, yes.
How he get
Oh, the unit. Good question. Must be minus 1 something, right? So the value is actually negative, but the unit is not negative.
Yes.
The value itself is negative.
So the hour does not have 1.5.
Why got negative? You got negative?
The unit don't have negative.
Yes.
But the value have a negative.
Then he put
Something wrong with my calculation. Tell
Then why
me.
he put negative?
ignore the negative.
Yeah, just
ignore the negative.
Huh?
The hour is 1. Which one? So many hours. Last one.
All the negative for the number.
Wow, well done. Give me your name.
units don't have negative.
Wow, well done, well done.
I know the way of the unit now. I don't get control of the thing.
Should we buy and then come back, tell me and eat?
Yeah. Oh, is this healthy?
Yeah, yours is healthy. Yeah, last year was
Okay.
better.
Yeah, sure.
Yeah, the unit is actually plus lah. The value in front is actually negative.
Maybe guys
Okay.
I don't know what. Shall we smell the whole?
Okay, Nana.
Nice smelling flower.
Last one. Before you can have the book, the best time in campus.
Best time.
Your lunch hour is the best time.
Yes.
Yes.
Best time.
Okay, concentrate. Because if you concentrate, you can go and buy your lunch earlier than your another diploma. Otherwise, you'll be crowded at the canteen. Okay. This is another important point for this topic, because when we are mentioning on the rate constant, okay, when we are talking about rate constant, you also need to identify which reactant that you are talking about. Okay, rate constant now will depend on the which component that you actually talking about. Why I say so? Because, for example, for this instance, right, the reaction considered does the following reaction: 2A plus B equal to C. Okay, and for this, what is the rate of reaction here? The rate of reaction, right? The rate of reaction you can see will depends on the stoichiometry in front of the reactants. This one minus the rate of dissipation of A is half compared to the rate of dissipation of B equal to 1 unit of the rate of occurrence of C. Okay? And by this, if you look at this, right, if we follow the reaction rate constant, we also depends on the which reactant we are talking about. Now, let's say in this equation, we will be focusing on the reactant A and reactant B. Okay, because if we measure the rate of dissipation of A, minus RA equal to KCA square CB. You see, this reaction is the elementary reaction. Therefore, when you need to figuring out the rate of reaction, number 2 is come from 2A here. Number 1 is actually from B here. Can this one can This one you have to know how to come out already by now. What if we measuring the rate of dissipation now, we focusing on the B instead. Okay, when we are focusing on the B instead, the rate of dissipation of B, yes, will be the same as concentration Ca square plus times Cb. But the K here will be different rate constant. K prime. We denote as K prime. So for this K prime, right, since the 1/2 minus RA equal to minus RB, so we can substitute these two together. We can equate these two together. We will get this one 4 minus RA, rate of dissipation of RA, and the rate of dissipation of RB.
Oh well, shit. Oh no.
Okay, since CA, CB here is the same, So we cross after that. Basically, you can see that. You can see that K from A it will be 2 times than the K of B. Okay?
What?
Therefore, when we want to
Oh.
come out with the rate constant, we have to indicate that which component that we are talking about. Okay? For example, if we are focusing on the reactant A, we put K. But if we have to come out with the rate constant of B, the if we have to come out with the rate of dissipation of B, the K will be different from the K from rate of dissipation of A. This one just to take note that the rate constant will depend on your reactant. Because the rate constant from A will be different from the rate constant from B. Okay, and this will be the end of your lecture for today. So see you tomorrow. So this week I see you every day. Tomorrow is one of the